In this video, we're going to look at how to write a formula for a geometric sequence. So the general formula for a geometric sequence is A sub n is equal to our first term a1 times r, the common ratio, to the power of n minus 1. So if we are told that the first term is 4 and the common ratio is 1/2, so a1 is equal to 4, r is equal to 1/2, we can very easily write a formula for an, which is just going to be our first term times our common ratio. And generally, our common ratio will be in parentheses. And we can leave it like this. There's not much more simplification that we need to do. We could simplify further, but then we end up with strange things happening with the exponents, and it's not necessary. If we have an example where the first term is 2, and our common ratio is -3, all we need to do is, again, plug it into our formula. an is equal to our first term times our common ratio to the power of n minus 1. So if we want to write an explicit rule for examples where we're not given the first term and the common ratio, we'll need to find one of those two things. So we're told here that the first term, a1, is equal to -1. So we have half of our formula already. But then we're told the ninth term is -256. So a9 is equal to -256. So we're going to use these 2 points to write a new equation. First, we know that an is equal to -1 times r to the power of n minus 1. We then know when n is equal to 9, an, which is a9, is equal to -256. So -256 is equal to -1 times r to the power of 9 minus 1. The negative signs cancel out on both sides, and we end up with r to the 8th power is equal to 256. Continuing, if we take the 8th root on both sides of our equation, we'll be able to find that r is equal to the 8th root of 256. Now, most calculators don't have a button for the 8th root, but what we can do in our calculator is change our 8 to an exponent of 1/8. And when I plug this into my calculator, let's see, 256 to the power of 1/8, it tells me that the 8th root of 256 is 2. So now we have everything we need to write our equation. So an is equal to -1 times 2 to the power of n minus 1. We could go a step further and simplify this as -2 to the power of n minus 1. And then the negative sign is outside the exponent because we don't have parentheses to include it. Or you could simply leave it in this first form. Either one is mathematically correct. To wrap up with one last example, suppose we have the 6th term is equal to 10, and the 7th term is equal to 30. Well, 6 and 7 are consecutive. So because we have 2 consecutive terms, we can discern that to go from 10 to 30, r must be 3. because 10 times 3 is 30. So now we have the option of, well, first, we have an is equal to our first term times 3 to the power of n minus 1. And now we have the option of using either a6 or a7. If I use a6, then I have 10 is equal to our first term times 3 to the power of 6 minus 1. So 10 is equal to a1 times 3 to the 5th power. 3 to the 5th power is 243. So we have 10 is equal to a1 times 243. And so to solve for a1, we divide both sides by 243. So our first term is equal to 10 divided by 243. And so our formula would be an is equal to 10 divided by 243, all multiplied by 3 times n to the first power. There we go. And that brings us to the end of our examples. You will see on the next 2 slides the practice for this lesson, as well as the graded homework for this lesson. There we go.